Hi everyone, I thought it might be useful if I made a quick video of an explanation for each of the classroom exercises. So number one, it says angle P is congruent to angle P. And what that's an example of is something called the reflexive property. And technically it's a reflexive property of congruence, but you can shorthand it like I did. The reflexive property is used very often to introduce something into a proof. So very often we have to introduce an item before we use it. All right, and number two, it says if line segment AB is congruent to CD and CD is congruent to EF, then we can make a connection from line segment AB to EF. All right. Now notice that there are congruent symbols. So unfortunately, we can't use substitution. Substitution is only a property of equality. And since we have congruence, this is an example of the transitive property. The key to the transitive property is looking for the pattern. So we have AB congruent to CD. CD is that bridge. CD congruent to EF. Then the first item mentioned has to be congruent to the last item. All right, and number three, it says if the length of RS is equal to the length of TW, then the length of TW is equal to the length of RS. So all that's changed here is the order. So this is an example of the symmetric property of equality. All right, and number four, we start off with the equation if x plus 5 equals 16, then x equals 11. So you will basically want to ask yourself, what would I do in order to get from the equation on the left to the answer on the right? And what you would do is you would subtract 5 from both sides. So this is an example of subtraction. And of course, it's a property of equality. If you just write subtraction, that's fine. Don't abbreviate subtraction or substitution, by the way. And number 5, it says if 5y is equal to negative 20, then y is equal to negative 4. So solving this equation, we would divide by 5. So this is an example of the division property of equality. And number 6, we have if z divided by 5 is equal to 10, then z is equal to 50. What you would do in this case to solve it is multiply both sides of the equation by 5. So it's an example of the multiplication property of equality. All right, and number 7, we have 2 and then parentheses a plus b. That leaves us with 2a plus 2b. We know that as the distributive property. What's outside the parentheses gets multiplied by everything inside. And if you didn't look at my notes online or you didn't hear me say this in class, you want to add this to the list. Okay. All right, our next one, it says if 2z minus 5 equals negative 3, then 2z is equal to 2. Think about what you would do to solve this equation. Your first step would be to add 5 to both sides. So it's an example of the addition property. Right. Number 9 says if 2x plus y is equal to 70 and y is equal to 3x, then 2x plus 3x is equal to 70. So what happened here is we have an equation, then we identified what y is equal to. Notice that there's a y here. And then in the last step, the y was replaced by 3x. So that's an example of the substitution property. And again, substitution is only a property of equality. And I want to take a look at number 10 as our last one here. It says if AB is equal to CD and CD is equal to EF, then AB is equal to EF. And EF is equal to 23. Then we can make this leap that AB, the very first thing mentioned, is equal to 23. Even though there are multiple steps here, it's still an example of the transitive property. Now, in this case, we could also write substitution because there are equal signs. If those had been congruent signs, we would have to stick with the transitive property.